This video is going to go through 4 word problems that apply inequalities to them. So before we do that, let's take a look at the different words that translate to our inequalities. First of all, we have more than. If I'm thinking of a number and it's more than 7, that means my number n would be 8 or 9 or 10 or 14 and a half or something like that, but it is greater than 7. So we use the greater than symbol. If I want to say my number is less than 7, I would say my number is less than 7. Some people remember less than because of the L here. If you're reading left to right, less than points to the left. Now let's look at these 4 because they seem to be a little bit troublesome to students at times. So when I see at least, so if I'm thinking of a number and it's at least 10, that means it could be 10 or it could be greater than 10. So I would say my number is greater than 10 or it could equal 10, so we put the bar under there. Now if you see the words is not less than, that really means the same as it's got to be greater than or it could be equal to. So for example, if I say I'm thinking of a number and it's not less than 10, well, if it's not less than 10, it could be equal 10 or it could be greater than 10. So again, I would use the same notation here. When you see at most, if I say, okay, I'm thinking of a number, it's at most 3. That means the biggest it could be is 3. So my number has got to be 3 or less than 3. So I would say n is less than or equal to 3. Now, if I look at this one, it says is not more than. So if I'm thinking of a number that is not more than 3, that means it could be equal to 3, but it might also be less than 3, so I have the same notation. Now, notice for both of these, I included this symbol. If it helps you to translate using that symbol first, go ahead and then change it over to the one that we are more familiar with, the less than or equal to and greater than or equal to. So let's look at just a few translating sentences. These are all the same except for the phrasing right here. This one says is less than, is not less than, and is at most. So let's do our translating. When I look at the phrase 4 times a number, that's 4 times n, so I can write 4n. Added to means plus. 12 is 12. Now, is less than translates to is less than 9. Now looking at the second one, I have the first part is the same, 4n plus 12. And then it says is not less than. Well, is not less than is this symbol. But as we've said before, I don't want you to leave that symbol in. Is not less than means it's the same as greater than or equal to, so we'll take that out and let's change it to greater than or equal to. And then for the last one, again I've got 4n plus 12, and now it says is at most 9. That means it's got to be 9 at its largest. So the most it could be is 9, but it could be less than 9. So we would say less than or equal to 9. Okay, so now let's look at our four word problems. Here's our first one. Ashley makes $200 a week plus 5% commission on everything she sells. How much does she sell to make at least $500 a week? So we're going to start on our word problem like we always do. Step 1, we write down what we're trying to find. So in this case, we're trying to find Ashley's sales. Now after I write that down, I have to have a let statement that defines the variable I'm using, so I'm going to let x equal Ashley's sales. Now before we come up with our inequality, we probably better come over here and review how you find commission. So when somebody works on commission, they usually have a base pay, which in Ashley's case is $200. And then she gets commission on her sales, and her commission is 5%. So her income is going to be $200 plus her commission. So the commission is calculated as 5% of her sales. Okay, so remember from when we did percents, when you want to find 5% of a number, that translates to 0.05 times your sales, which we already said was X. We're letting X equal her sales. Okay, so this is how much she makes. All this together is how much she makes in a week. Now what we want that to be is at least $500. So this amount has to be $500 or more. So if I put my 500 over here, it's got to either equal 500 or be greater than 500 in order for it to be at least 500. So this is my inequality. Now that I have my inequality written here, I just need to use the knowledge that I already have about how do we solve inequalities to get an answer. So when we solve an inequality like this, we first have to isolate the variable term. So I subtract 200 from both sides. That leaves me with 0.05x greater than or equal to 300. Divide both sides by 0.05 to undo this multiplication, and I get x is greater than or equal to 6,000. Circle that, and that's your step 4. Now step 5 is my conclusion, so therefore, but before I write anything down, let's kind of think through this. X is her sales, and they have to be greater than or equal to $6,000. So the best way to write that would just be to say Ashley's sales need to be at least $6,000. So there we have our conclusion. Ashley's sales must be at least $6,000. Okay, let's look at another one. Okay, here's the next problem. A suit that costs $100 currently sells for $250. How much of a discount rate can be offered without the store actually losing money? So let's go ahead and write our find statement. Okay, I've got step 1, find the discount rate, and step 2, I'm going to let D represent the discount rate, but remember anytime you're using a rate, which is a percent, it has to be represented as a decimal. Now, before we go into setting up our inequality, we have to remind ourselves what it means. What do we do with a discount rate? The way a discount rate is used is we take our selling price and then we subtract the discount. Okay, so now we need to look at where that discount comes from. The discount is going to be a percent of the selling price. So in our case, our selling price is currently $250. So if I take off a discount, that's going to be a percent of the selling price. Well, the thing is I don't know what that discount rate is, so this percent is really my unknown. Oops, sorry, we're using D here. So this is going to be my D. So I'm going to subtract my discount rate as a percent of, which means times, my selling price. So if I take $250 and subtract a percentage of that, that's going to be my new selling price. That's my discounted selling price. And from the problem up here, we want the new price to not drop below $100, because if it drops below $100, the store's going to lose money. So let's see what we have here. We're going to write down $250 minus the discount, which is $250 times our discount rate, and we want all of that to be at least $100. So it's got to be greater than or equal to $100. So let's solve that. Okay, to solve this, I've got my variable term here, which means I need to get rid of the 250. Now this is a positive 250, so to get rid of it, I'm going to subtract 250 on both sides. Now please don't lose this minus sign. It belongs to the 250D. So it's a negative 250D greater than or equal to negative 150. Now, I stopped here because I want to just make sure that you remember our rule. Notice that we're dividing by a negative 250, which means I have got to right away make this less than or equal to. When you multiply or divide on both sides by a negative number, remember that that means you have to flip the inequality. So my answer actually ends up being D is less than or equal to 0.6. Okay, now remember that to turn that then into a percent, I'm going to have to go 2 places to the right. So my answer is actually D is less than or equal to 60%. So circle that, and that's our step 4. So when I write my conclusion, I know that my discount rate must be less than or equal to 60%. So here's my step 5. Therefore, the discount rate is 60% or less. So the key on this one was making sure you remember that when you divide both sides by a negative, you must flip that inequality. Okay, this next problem involves interest. If Angelica can get 10% interest compounded annually, how much must she put aside to have at least $1,000 in savings a year from now? We're told to use this formula, so let's just review what that means. S stands for the amount in the account. P stands for the principal, that's the amount that you start with. I stands for the interest rate, and N is the number of annual interest payments. Now for this problem, since it's compounded annually, that means once per year. So in our problem, N is going to be 1 because we're looking at the savings 1 year from now. That means 1 interest payment. Okay, so let's get our find written. Okay, so we're trying to find the minimum amount to invest in order to get at least $1,000 in savings at the end of a year. So I'm going to let P equal the amount to invest. P is going to stand for my principal. So I'm going to use this formula to calculate how much I'm going to have in my account at the end of 1 year. So I'm going to use this formula. I'm going to start with P, and then in the parentheses I'm going to have 1 plus I. Here's my interest rate. 10% as a decimal is 0.10, and then I'm going to raise that to N, which in our problem is 1 because we're investing it for 1 year. So that's going to be a 1. All right, so what do we want that to equal? Well, we want it to be at least $1,000. So that amount must be at least 1,000. That means it could be 1,000 or it could be greater. So this is what I need to solve. So let's clean that up a little bit. I've got P, and then inside the parentheses 1 plus 0.10 is just 1.1. And that amount is supposed to be greater than 1,000. Well, if I'm going to solve that, I've got multiplication, and I need to undo that by dividing both sides by 1.1. So when I do that, I end up with P is greater than or equal to 909.09. So if you end up with an answer that doesn't come out evenly, if you're working with dollars, take it out to the nearest cent. Okay, so that's our P. That means if I'm investing money at 10% annual interest, then I've got to invest at least $909.09 in order to end up with $1,000 a year from now. So we write our step 5 conclusion. Therefore, she must invest at least $909.09. Okay, here's the last problem. If peanuts cost $1 per pound and cashews cost $2.25 per pound, how much of each should go in a 50-pound mixture if you want to sell it for no more than $1.75 per pound? Now, mixture problems can be kind of fun because you get to draw buckets. So our step 1 is going to stay the same. I'm going to write down what I'm trying to find. And in this case, I'm trying to find the number of pounds of each. So I'm looking for the number of pounds of peanuts and cashews. Now for step 2, instead of a let statement, we're going to draw buckets, because I'm going to take a mixture of peanuts, so I'll do P for peanuts. I'm going to add a bucket of cashews, so C for cashews, and I'm going to end up with a mix. So I'm going to write mix over here. So what happens when you have a problem like this is in the bottom of the buckets I put down how much I have of each. Now the only thing I know is that I have 50 pounds total. So if I let X be the number of peanuts that I have, the number of cashews would be 50 pounds, take away however many that was. So the way that we write that is 50 minus X. Okay, now in the middle of the bucket I'm going to put my unit price. So for peanuts they are $1 per pound, cashews are $2.25. And here's another hint. Instead of writing it in dollars, because then you have decimal points, let's write this in cents. So $1 per pound is going to be 100 cents per pound. For the cashews it's going to be 225 cents per pound. And I want my mix to be no more than $1.75 per pound. Alright, so I need to look at this word right here before I go any further, because it says I want it to be no more than $1.75 per pound. So that means when I add the price, the value of the peanuts and the value of the cashews, I want it to be no more than $1.75 per pound. So I'm going to have to say that I want my total price for the peanuts and cashews, when I mix them together, I want that mix to be $1.75 per pound or less. So I'm going to need to have this inequality here. So now let's go ahead and get our equation. When you have a bucket equation, all you have to do is multiply what's in the buckets and write down the symbols. So I've got 100 cents times X plus 225 cents times 50 minus X, and that is less than or equal to, whoops, we better take that, we want that to be written in cents, so instead of 1.75 that should be a 175. So I've got 175 times 50. So when we do bucket equations, the product of each bucket stands for its value. So I end up with this equation, and actually an inequality, and that's what I need to solve. So before I get busy and solve it, I probably should do the multiplication, which in this case I've got a product here I need to multiply, and then I need to use distributive on this one. Once I've cleared the parentheses, I see that I can combine a couple like terms. I've got a 100x and I've got a -1 or negative 225x. So I'll combine those and then I'll isolate my variable term. Okay, let's see what we've done so far. I combined the 100x and the negative 225x. That gives me a minus 125x. And now I need to isolate this variable term by getting rid of the 11,250. So I've got it subtracted from both sides. Please don't lose this minus sign. It belongs to the 125x. So I've got negative 125x is less than or equal to negative 2,500. Now, I need to divide both sides by negative 125. But that should set off some little warning bells for you, because as soon as you do that, you've got to flip this. So I'm dividing both sides by a negative 125, and what I get then is x is greater than or equal to a positive 20. Okay, so what does that mean? Well, that means, where was x? X was the number of pounds of peanuts. So that means I've got to have at least I need 20 pounds of peanuts, and then let's see, what's 50 minus 20? 50 minus 20, that would be 30. So if I want my mix to be no more than $1.75 per pound, that means I need to have 20 pounds of peanuts and 30 pounds of cashew. That's the most I can have. So let's talk about this just a little bit. If X has got to be greater than or equal to 20, that's the number of pounds of peanuts. Now I'm looking at a 50-pound mix, but this says that at least 20 pounds has to be peanuts. So I could have 20 pounds of peanuts and 30 pounds of cashews, or maybe I have 25 pounds of peanuts. Then I would have 25 pounds of cashews. If I have 40 pounds of peanuts, I'd have 10 pounds of cashews. But the key to making this work is that the number of peanuts has to be at least 20 pounds. And then the number of cashews would be calculated depending on how many pounds I decide on for the peanuts. But that has to be greater than 20.